In this video, we're going to discuss other sugars which join glycolysis, because it's not just glucose that we consume in our diet. We consume many different types of sugars, which are listed here: sucrose, lactose, and maltose. So we've got fructose plus glucose, which equals sucrose. So when we eat sucrose in our diet, we need to metabolize it into something that the body can consume. So we first break it down into a fructose plus a glucose, and then that fructose goes through a metabolic pathway to then be broken down, which is what I'll go through in this video. And then we've got galactose plus glucose, which equals lactose. So when we get it into the body, we break it down into galactose and into glucose, and then that galactose can be further broken down in a different pathway, which I'll also go through this video. And then I thought it was also worth noting that glucose plus glucose gives you a maltose, just something worth noting, but not something that will necessarily come up when it comes to biological chemistry. So let's get started with how fructose is broken down. So remember, in our diet we might consume sucrose, and fructose plus glucose equals sucrose. So let's look at what happens to that fructose. So first up, we get that fructose in our body, and then we've got the enzyme fructokinase, and ATP is converted to an ADP in this process, and we get fructose 1-phosphate. So we've got kinase in the name of the enzyme. We know that an ATP is involved, and that's how this reaction occurs. So then we have fructose 1-phosphate becoming either DHAP, which can join in glycolysis, or becoming glyceraldehyde. And this enzyme that does both of those reactions is aldolase B. So then after that, the glyceraldehyde can be converted to glyceraldehyde 3-phosphate, which can join into glycolysis through the enzyme triose kinase. And we know that kinase is there, so our mind should be flashing. There's got to be an ATP involved. And in this case, an ATP becomes an ADP. So now we've got two substances that can enter glycolysis. We've got glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. So they both join in glycolysis. So glyceraldehyde 3-phosphate joins in glycolysis, and so does dihydroxyacetone phosphate. So now we've looked at how fructose is metabolized. I want to note that, and note this separately, that this metabolism of fructose happens in the liver, and it bypasses that important PKF2 step that happens in glycolysis, and is therefore highly unregulated and causes the buildup of fat in the body. So keep that in mind, because that means that we probably wouldn't want to be consuming heaps of fructose in our diet. We would want to avoid sucrose, which contains fructose, because that could cause a buildup of fat, which is unhealthy for our bodies. So I just thought I'd note that separately. Before we move on to galactose, which can be found as part of lactose. It's in the name, galactose. So when we have lactose in our body, we break it down to glucose plus galactose, and then that galactose goes through this following process. So galactose becomes galactose 1-phosphate by the enzyme galactokinase. Kinase, again, your mind should be flashing. There's an ATP involved. An ATP becomes an ADP. Then we've got galactose 1-phosphate, which undergoes an interesting reaction whereby galactose 1-phosphate uridyl transferase makes sure to transfer the UDP glucose to a UDP galactose in this process. So it's a bit different, not involving the typical ATP that we're used to. And then in between this UDP glucose and this UDP galactose is an epimerase. So it's a bit different to what we normally see, but I would just put that one in your mind and keep it in your memory, that we've got some transfer of substances going on here. So we've got a UDP glucose becoming a UDP galactose in order to get from galactose 1-phosphate to glucose 1-phosphate. So if you just want to write that out a few times, it should sink in. So then we have glucose 1-phosphate becoming glucose 6-phosphate. And this enzyme is phosphoglucomutase that does this. And this is quite a common reaction. So just make sure that you've got this one in your mind, phosphoglucomutase. So this glucose 6-phosphate can either go to the liver and undergo gluconeogenesis, as I've written in orange, and it will become glucose, or it can be broken down to glucose 6-phosphate. The glucose 6-phosphate can be broken down, rather, by glycolysis in other tissues. Remember, we can only produce glucose in the liver. So that's how galactose gets broken down into glucose and is able to be metabolized in the body. So we looked at fructose and galactose in this video as other sugars which join glycolysis.